Alright guys, so today we're going to be talking about intersecting points and planes. And first of all, I just want you to go ahead and pause the video and think about for a minute what does the intersection means in everyday life. What is an intersection? Alright, so hopefully you thought of an intersection like a street intersection. You know, where you've got two roads that are crossing, right? And they give you, an intersection where cars are driving. So that's a good example in everyday life of an intersection, and it can give you an idea of what we're talking about in math when we talk about an intersection. Okay, so an intersection is where two lines intersect, cross each other, or two planes cross each other. So right here on this plane right here, we've got some points and lines on this plane V. Where does AX intersect CM? So we're looking at the line AX and the line CM, and we can see that they intersect at the point N. Okay, so they intersect at a point. Two lines will intersect at one point. Okay, anytime two lines cross, it's one point that they're going to cross at. Okay, so we're just going to name the point. Remember, you name a point with one letter N. Does RN intersect AX? Well, right here's RN. Right here's AX. Do those intersect? Yes. And it says, if so, where? Well, they intersect at the same point, point N. Okay, do you see any other intersections besides AX intersecting CM and AX intersecting RN? Hopefully you notice that AX and CM also intersect at point N. Okay, so yes, we do see an intersection between AX and CM. Intersect at the point N as well. All right, so that's a little bit about intersections. And what do you notice when two lines intersect? Again, we pointed that out already. They intersect at a point, okay, at one specific point. All right, so now looking at a cube, based on the cube, name the intersection of FG and FB. So right here is FG, and FB is right here. Where do those two lines intersect? They should intersect at a point. Two lines intersect at a point, and we can see they intersect at point F. Notice that that is the letter they share, right? Two lines are going to intersect at the letter that they share. A lot of times, not always, but in that situation they do. Now, what is the intersection of EH and DH? EH, DH intersect at point H. So pretty basic right there. What we include about the intersection of two lines? Again, we said that they're going to intersect at a point. Okay, two lines intersect at one point. Okay, so based on the postulate that two lines intersect at exactly one point, make a prediction about how two planes intersect. Okay, what do you think is going to happen when two planes intersect? So go ahead and think about that for a second. Pause the video, give it some thought. Okay, so keep that thought in mind about how the planes intersect, and we'll see what happens right here on this problem. So it says, based on the cube, name the intersection of plane HGF and plane ABF. So let's highlight real quick plane HGF. So right here's H, over here's G, and right here's F. So those 3 points make this top plane of the cube. And the other plane is the plane ABF. Okay, A, B, and F. Well, those 3 are on the front plane. So those make up this front plane right here. So I draw that plane, outline that plane. So notice they intersect where the red and blue lines connect. Okay, so see we got the red and blue lines that are overlapping right here. So those two planes are hitting each other to form a line. So we talked about how two lines intersect to form one point. We can see here that when these two planes intersect, they come together to make a line. And that line is the line from point E all the way across to point F. So the intersection of two planes is the line segment EF. Okay? So right here, it's going to be a segment, EF. So we put the little segment line over top of EF. Okay, next, based on the cube, name the intersection of plane EHD and HGC. So I'm going to go ahead and pause the video, let you guys try that one on your own, and I'll tell you the answer. All right, so EHD and HGC are going to intersect at the line HD, line segment HD. Okay, you can see the plane EHD is outlined in green and plane HGC is outlined in blue. Those two planes meet right here. The green and blue lines overlap right there. So that is from H to D. So HD is the line segment that those two planes intersect at. What do you notice about the intersection of two planes? You know, we pointed that out already, that two planes intersect to form a line segment, line or line segment, depending on if you're talking about an infinite plane. Right here, these planes don't go to infinity. They're making cubes, so they stop. So they form a line, or you could say a segment, either one. The point is, they don't just meet at a point. A lot of you will think that planes meet at one point. They don't. Lines meet at a point. Planes meet at a line. Okay, what's the difference between parallel lines and skew lines? Okay, so maybe think about that. I know you guys might have some background with parallel lines. Might not so much with skew lines, but give that some thought so you can figure it out. All right, so based on this cube, name all segments parallel to AB. Okay, so let's identify where is AB. AB is right here. All right, so it's this segment. So parallel lines are lines that run right alongside AB, okay, kind of like train tracks, and are never going to touch AB. That's the key characteristic for parallel lines, is they never touch. So which of these other segments on the cube run right alongside AB and are never going to touch them? Well, you can see up here DC does. It's parallel. And then down here, HG is parallel, and EF is parallel. So those three, you can see, run alongside AB and are never going to touch it. They make parallel lines. So we can list those right here. We got DC, we got EF, and we've got HG. Those three are parallel to AB. Okay, let's let you guys try this one, see if you can figure out what is parallel to the line segment CG. Give that one a try. You're able to identify the segments HD, AE, and BF are all parallel to CG. Okay, you can see right here is CG on the far right side, right there. And the ones parallel that run, notice CG runs up and down. The other ones that run up and down are BF, AE, and DH. Okay, so those three are the ones parallel to CG. Okay, now we're going to talk about lines that are perpendicular to AB. So perpendicular are again lines that form a 90-degree angle. So which lines connect to AB to make a 90-degree angle? So first of all, they got to touch. We got to make sure they touch right here. So let's identify ones that touch AB. Okay, BC touches to make a 90-degree angle, because that's a square up there. Squares all have 90-degree angles. DA also forms a 90-degree angle right here. And then what else touches AB? Well, this line right here, AE, and then the line FB. So those are the four that are perpendicular to AB. So we would say AE, FB, or BF, either one's fine. And then we could say AD or DA, and then BC, or of course you can say CB. Either one's fine. Order doesn't matter when talking about segments. So those four are perpendicular to AB. All right, go ahead and pause the video. See if you can figure out what segments are perpendicular to CG. Okay, so trying to figure out the segments perpendicular to CG. Hopefully you got these four: DC, BC, FG, and HG. Again, those letters can be flip-flopped. Okay, but you can see up here, CG is this far right segment. And the four that intersect at a 90-degree angle are DC across the top, BC going front to back, HG coming across the back, and FG going front to back. So those are the ones that are making 90-degree angles with CG. All right, last kind of line we're going to talk about are skew lines. Okay, so we're going to name all segments that are skew to EF. Now, here's the difference with a skew line. A skew line doesn't touch each other. Okay, skew lines don't touch each other, but they're not in the same plane as each other either. So one, it's kind of like one passes by the other. Instead of running right alongside, they kind of pass by each other. All right, so if we look at EF, we're going to see what's skew to EF. Remember, these lines are not going to touch EF, but they don't run beside it. They just kind of pass past it. They just go past it. So if we look up here, see FG is one on the bottom, that intersects it. So that doesn't go past it. And then EH down here, it intersects, right? It doesn't just go by it. HG across the back, that's parallel to it because it runs right alongside it the whole time. So like, well, what kind of lines are you talking about then? Well, let's go up to the top and look at some. So you got AB. Well, AB is parallel. AD. Is AD parallel? No. Does it touch it? No. So this is a line that's skewed because it's just going to pass over top of EF. It's never going to touch it and doesn't run right along beside it. So that's one. AD. Well, there's another one up there too. BC. It's skewed. And then the only ones we haven't really checked are the ones on the back. So you can see right here that this one, it's skewed because DH is just going to pass by EF without touching it, and it's not parallel. And then CG is the other one. It'll just pass by EF, never touching it. So those are your skew lines to EF. All right, see if you can identify what the skew lines are to DH. Go ahead and pause and give it a try. Here are the 4 lines that are skewed to DH: AB, BC, EF, and FG. Okay, and you can see it in the picture. You got DH back here along the back side. So you want lines, again, that don't run into DH. They're not going to hit it, and they're also not going to run right along beside it. So AB is one. It's just going to go right in front of it and pass by, never touch it. Same thing with BC. It just runs back behind it, never touches it. EF, same thing, just runs right along in front, and FG runs right beside it, past it, never touches it. And they're not parallel because they're not next to each other. They're not in the same plane as each other. Okay, if you notice, DH is runs along this back plane. AB is out here running left to right along this front plane. So those two can't be in the same plane as each other. They're never going to intersect. Okay. All right. So last thing, parallel planes. Okay. So this kind of makes sense. You got planes that run right along beside each other. We want to name 2 sets of planes that are parallel. So remember, when you're naming planes, okay, you got to use 3 letters. Before, in the last few slides, we've been naming segments or lines, so we've been just using 2 letters. When you start naming planes, they got to be 3 letters. So there's a lot of options right here. You could use the front plane, which is this one, and the back plane. These planes are parallel. They're just planes that go up, front, and back, right along, and just kind of follow each other side by side, going straight up and down. So we can name this as plane ABE. You can use any 3 of those letters, and plane, the one on the back, we call DCG. Doesn't really matter as long as you use 3 of those 4 letters. So that's one set of parallel planes. If you want to name another set, well, we got the front and back plane, and you could either use the left and right plane, or you can use the top and bottom plane. I'll do the top and bottom plane. So let's say the top plane, plane ABC, and the bottom plane, we can call it plane EFG. Okay, those 2 planes are also parallel. And again, the left and right ones would be a 3rd example of parallel planes. Okay, so see if you can figure out 2 sets of parallel planes in this room, in the classroom. What would be 2 planes that would be parallel in the classroom? So just a couple of examples would be the ceiling and the floor in the room. You got the front wall and the back wall of the room. You could also say the shelves. Those shelves are stacked in planes that are parallel. And then you could say the trays where you turn your stuff in. Those are stacked up, and those trays would be parallel to each other. So just some examples, real-life examples of parallel planes. All right, that'll do it for this lesson. And it's time to practice. Appreciate your all's attention, and have a good one.